commonly available both LHS side and RHS side, so that we can eliminate it. Similarly, here instead of dV, we again converted into del x into ds. Del x is the length, ds is the surface area. So we are converted, then we cancel it, and finally the dn1 it should be equal to dn1 minus dn2 is equal to, that is the volume charge density, that is the total volume is available. So it means that dn1 it should be already we proved here, the dn1 normal component of the electric flux density of the medium 1 it should be equal to the medium 2. So that is the dn1 it should be equal to d1 cos theta 1, that is the another one notation. Up to this the case 2 is getting over. So from these two cases we can draw this diagram. So here we are considering two different medium, dn1, dn2, similarly et1 and et2. The et1 and et2 both are equal and opposite. Similarly dn1, dn2 also both are equal and opposite. That is why while we are making summation, so the resultant value is 0. That is why here we find it that the et1 it should be equal to et2. The et1 as well as et2 both are equal and opposites. That is here mentioned the direction. Et1 is opposite direction, then et2 is this direction. Okay, that is both are et1 and et2 is both are equal and opposite. Similarly, dn1 and dn2 both are equal and opposite. So the electric flux intensity and the electric field intensity have the angle theta 1. It is the medium 1. Similarly, it's have the permittivity, that is the epsilon 1. This all it's having for the medium 2. Okay, so we are passing the rays like electric flux density or field intensity while it is developing. So it has been, we have some angle, that is the theta 1. Similarly, here it may be reflected. So here it is the theta 2. So in terms of angle, we need to find it out. So that is the normal component of electric flux density. It should be equal to available electric flux density into the cos theta 1. Similarly, dn2 is also the cos theta 2. So it means that here the angle, the theta 1, d1 into cos theta 1, then d2 into cos theta 2. That is the first case. Similarly, et1 and et2. So here that is the et1, e1 into cos sin theta 1 and e2 into sin theta 2. So we written like that. So we need to find it out, the resultant angle and permittivity of the medium. So the dn1 equal to dn2. So we already obtained. et1 it should be equal to et2. That also we obtained from the two different cases. So the dn1 it should be equal, already derived the expression here. dn1 it should be equal d1 cos theta 1, d2 it should be equal d2 cos theta 2. So you can substitute in the equation 1 as well as equation 2. So you may get like that. So you can divide both the expression, because without the electric flux without the electric field, the electric flux density it will never will be appear, right? So the both are it's essential. So you may divide in the both the expression. So the e1 by d1, so the sin by cos tan theta 1. Similarly e2 by d2, so here tan theta 2. So we know the relationship between the electric flux density and the field intensity. So d1 it should be equal to epsilon 1 into e1. So in terms of d1 you can replace it epsilon 1 into e1. So the both the e1 it is getting cancelled. Similarly this side also it is getting cancelled. The resultant value here tan theta 2 divided by epsilon 2 will come. Here tan theta 1 divided by epsilon 1 it will come. So once you can move all the thetas and the permittivity in the one side, so you can segregate it. The tan theta 1, here already tan theta 1 is there, so you can bring it here. The tan theta 1 divided by tan theta 2, it should be equal epsilon 1 by epsilon 2. That is the boundary conditions of the electric field. Okay, here one thing you should remember, the electric field intensity of the medium 1 it should be equal to medium 2. Similarly, electric flux density of the medium 1 it should be equal to medium 2. Okay, so you have to consider these two expression. From this you can find this all expression, and finally you derive it, and tan theta 1 divided by tan theta 2 equal to epsilon 1 divided by epsilon 2. That is the epsilon is the relative permittivity of the medium 1, it should be equal to the medium 2, but here it's have the angle, it depends on the angle, it may getting varied, right? That is we derive. That is the boundary condition of electric field. Okay, if you have doubt you may ask.